In this example, we have our structure starting out with something in parentheses. So I don't usually like to start with those. So what I'll do is move over to the next atom, which is this CH, and draw it out. And that gives us a nice starting point. Now, from there, we can draw in these two methyl groups, the CH3s in parentheses, are attached to that carbon that I've highlighted. So let's draw those in. Here's the first one, and here's the second one. Okay, next we have another CH, and that's the one in red. Let's write that in. Next we have yet another CH. I'll put this one in green. Then we have a CH2 and a Cl. Okay, now at this point, bells and whistles should be going off, and you should spot that we have two carbons that don't have an ideal number of bonds. Here and here. These two carbons only have 3 bonds. So what that means is we need to turn that single bond into a double bond such that both of those carbons have 4 bonds. So I'll make this a double bond, and now we have a correct structure. All right, let's turn this into a skeletal structure. As always, find our longest chain that we can highlight, and that's going to be this that we have here horizontally. Let's go ahead and number our atoms from left to right. 6 atoms. I'm going to draw a zigzag. Okay, let's put in any heteroatoms. So atom 6 is a chlorine, not a carbon. I'll put that in. Then we'll add any groups attached to this main chain. Carbon 2, we have a CH3 group. So draw a line, and the terminus of that represents a CH3. One other thing we have is between carbons 3 and 4, we have a double bond. And I'm going to draw that double bond in. Right. Later in the semester, we're going to see that there's a couple variations of this double bond that you can draw, but for right now, just drawing it in the simple zigzag framework like we did is perfectly fine.